So I'm gonna work on that. All right. We gotta back up and do number 21. How many social security numbers are possible? So let's think about this for a minute.
9 digits.
Wait, is Rock's stuff gone? Did he take it with him?
Yeah.
Oh, I didn't know. I thought he left it your Rock. When he went to get blood. How many social security numbers are possible? Well, social security numbers are 3 digits and then 2 and then 4. That's what your social security number looks like.
So we have to have some common sense going through these tests.
What?
We have to have some common sense.
Ms. Ford, do you have your social security number memorized?
Yes.
What is it?
They really thought they were gonna get you with that.
Do you really want to steal my identity, Joe? I mean, really, of all the people in the world,
Actually, yeah, I would.
you want to pick the oldest, poorest person you
I
know?
would love to. I
would
love to be Miss Ford.
Here we go. All arrangements are possible. So I have a feeling that in the real Social Security world, you're not allowed to have, for example, 0, 0, 0, 0, 0, 0, 0, 0, 0. I think there are probably rules about that, but in this problem, we're saying anything goes. So, how many would be possible?
9.
10.
10.
Oh,
10.
10, 10, 10, 10.
10.
That can be anything.
10. Any possibility.
0, 1 through 9, 8,
So 0 through 9.
Well, I thought it was 3 like 1 digit. How can it be 10?
Because digit can be anything. The digit can be anything, 0 to 10.
You have 10 choices for that blank. So your number could start with 0. It could start with 1, 2, 3, or whatever. So there's 10 ways.
Yeah, you're
the
good.
number should start.
It could be actually 10.
Huh?
It could actually be 10.
No, there are 10 choices.
10 options.
I was
So 10 to the third, 10 to the
Now,
We're good.
what would the answer be?
10 times 10 times 10.
So are there like 9 of them? So 10 to the 9? I think that's a billion.
That's like a billion.
It's like a billion.
That might be a billion. No, bruh.
Guys, stop it. Stop it. Alright, you don't want to have a pop quiz because I'm angry, right? That would not be good for anyone. So listen, this is the most, a billion is the most you could possibly have because that's all the options there are. We know that when we start putting restrictions in, like maybe the rules say that can't be 0. Okay, then that would only be a 9. Maybe the rules say they can't all be the same number, so you can't have 5, 5, 5, 5, 5, 5, you can't have that. That would take some more options away. So at the most, there's a billion, but we know in reality there's some less than that. Does anyone see a potential problem with the system? Yeah?
Why is it different from the digits one? Isn't the digits one similar where it's like 4, 2, 3? How the digits one was you had 3, 2, and 1 digit.
Does anyone know what he's talking about?
He's like, I think he's saying,
Why did, I was saying, why did you not add them like the digit
Oh,
problem?
no. Because when you make a social security number, you don't make this part, or this part, or this part. You make this part, and this part, and this part. And anytime you're doing all of it together, and it's time. Okay. Wait.
Oh, there's like a cap amount of.
Exactly. When you get to however many possibilities you have, then you're either going to have to create
Another
digit, or start recycling numbers, because you're going to run out of possibilities at some point. And read the next question, because that actually happened not very long ago. How many telephone numbers are possible in 317 area code. So you know that you have the 317, okay, that's your area code.
10.
And then you have 3 of those, and then you have 4 of those, right? That's what your phone number, most of your phone numbers start with 317, not all, but most of them.
And then 319.
Now,
Well, we use mine as a demonstration, mine number. 219.
they're saying no other restrictions, so that would be this. Alright, so that would be 10 to the 7th, which is about 10 million, alright? How many phone numbers are possible if you allow every combination? How many are possible in the 317 area code? 10 million. 10 times 10 times 10, 7 times. Now, I want you to think about this for a minute. Back when I was your age, way back, when I was your age, my family of 7 lived in a house with 1 phone. There was 1 phone for all 7 people. Now, at this moment in time, how many phones does that family of 7 have? 7 and maybe 8 if there's still a home phone in there, right? Maybe 9 if you're one of those people, if your dad maybe is one of those people that has a personal phone and a work phone. So all of a sudden, that 10 million didn't go far enough because there were too many phones. Every person basically had at least 1 phone. So somebody said, mentioned the 219 area code. 219, when I was your age, was the entire northern part of the state. They ran out of phone numbers, so they created a new area code, 260,
Okay.
and then that is part of the northern part of the state. And every time you put in a new area code, you introduce 10 million more numbers. So
Makes sense.
that, I mean, it happened. They ran out of numbers, so they had.
So aren't we gonna run out of area codes as well?
Well, it's possible, then your area code becomes 4 digits.
It's possible.
As if we.
Isn't 216, isn't that Ohio now?
219 is still Indiana. I don't know what 216 is.
219 is Gary.
219, yeah.
219 is, it's
Holy glaze.
So, all right, here we go, here we go. Let's go back down to, number 25. I'm ready for 25. Stop it. Shake,
Yeah, why are we?
shake.
Gosh.
How many, or tell me, explain why at least 2 students must have the same first and last initial at Cathedral. So in other words, his initials AC, right? His initials SM, DH, and so on.
Actually, SAN.
How do I know first and last? First and last initial.
Yeah,
How do I know for sure, guaranteed, that at least 2 people out there have the same initials? Now, they may not be AC, but somebody out there has to match. We have it right here. JG, JG. We have 2 of them right here. How do I know that has to happen?
There's more than 66.
Exactly. She says, Mrs. Ford, if you take every possible combination, 26 first initials, 26 second initials, that includes ZZ and XY. I mean, that includes everything. There's only 676. How many kids are at Cathedral?
1,000.
More than that.
1,200.
So somebody matches, right?
Somebody matches.
Somebody matches. They have to.
There might be multiple matches.
All right, 26. I want you to read. I want you to read.
Whoa, that's nice.
I want you to read question A and question B for number 26. They both involve a class of 20 and choosing two. Now, read the two questions and tell me if you think they're just different words for the same question, or if they are truly two different questions. 26A and B. I hear one vote for same question.
I go with same.
Same. Probably different, but
They are different.
I think it's they're literally the same thing.
They are different.
No, they're A and B, so they have to be different.
He's the difference.
I'm going with John Frederick Jones.
They're different.
They're different.
Alright,
They're different.
really, there's a famous mathematician, Carl Friedrich Gauss.
Because two first names.
Spelled different.
Jack Gauss and John Frederick Jones.
Spelled different. Alright, question A. I want you to think about this for a minute. There's 20 of you. I am gonna pick a president. And then I'm gonna pick a vice president. So, if I pick him as president and him as vice president,
I like that. That's a good.
wouldn't that be different than picking him as president and him as vice president? Yeah. In other words, the order I'm making my choice matters. If you get picked first, you're president. If you get picked second, you are vice president.
Yeah.
Right? When order matters, it's one of our permutations. 20 P2. 20 kids picking two. That would be the same, this is exactly the same as 20 times 19. You have 20 choices for president, and then you only have 19 choices for vice president. So you can do this problem either way. The P, you guys, this is important. The P is used when the order of choice matters. If I am picking two different jobs, then the order I pick them matters.
yeah.
Now, look at question B. I'm still picking two leaders,
They have the same power.
but they have the
So it's
same
20-20.
power. No, it wouldn't be 20-20. In fact, this is a whole new concept. I am picking 20 people, I mean, I have 20 people, I'm picking two,
18.
and order doesn't matter. This is called a combination.
Because it's the same, so it doesn't matter.
I am picking a combination of two people, and the order I pick them doesn't matter. So, you cannot draw blanks for this problem, because as soon as you put down a blank, you have order for second. No blanks. If you're picking two people for the same job, it's 20C2. Now, I'm not gonna talk about this anymore, one more time. If I am picking these two to be on my council, does it matter to Sam if he gets picked first or second? No.
I mean, it depends on how he is.
If he's president, vice president, then it matters, but not if he's gonna be doing the same job.
Yeah.
True.
So, on your calculator, where the P button and the factorial button are, you have the C button. So you'll type 20, math, prob, NCR 2. And the answer is 190.
That's what I get.
So, boys and girls, as you do these problems, and it's all word problems, as you do them, you are going to have to decide, is this a P or a C? And it all boils down to is when I pick my people, or whatever, does order matter? Okay? Alright, so you do 27. 27 A and B. 27 A and B. You do it right now.
13. It's over.
Figure out what's going on. 27 A and B.
Oh, really? I can't see. Yeah. It's like 3.5. Not bad. Yeah, not bad at all.
This is a HPC.
How many, what's like student body? I don't even know. It's not like small, but it's like 80, it's like,
I hope you figured out that one of these is gonna be a 13C4 and one is gonna be a 13P4.
Yeah.
Because we have 13 people and we're picking 4 of them.
I think I got it. I got it.
So which one is which? A is the C,
A
B
is a
is
C.
the
B
P.
is the P, yep.
Does everybody understand that?
Yup.
All right. Now we got another new idea.
I like to see it already.
All right. Now I need to tell you, remind you, that if I were taking 8 people and seating them on a log, how many ways could I do that? 8 people on a log is 8 factorial, okay? Now, I need you to understand what happens when I put them in a circle. Because when I put them in a circle, like number 28, the rules change, all right? 8 people in a line is 8 factorial, all the time, period. What happens when I put them in a circle? Well, I'm not gonna do 8 because it's too many. I'm gonna do just 3 items, okay? So let's say I have an apple, a banana, and a carrot, and I'm gonna arrange them on a circular plate, okay? So I'm not putting them in a line, I'm not doing like apple, banana, carrot in a line. There would be 3 factorial or 6 ways to do that. So I'm gonna look at those 6 ways on a circular plate. So apple, banana, carrot, apple, banana, carrot, apple, carrot. I think I'm getting them all here. I think I got them all. Okay. So there are the 6 orders that would be out in a row. I just put them around the circle. Look at those plates. And remember, I put the fruit on a plate or vegetable, whatever it is. Take a look at those, and do you notice anything about those arrangements?
The triangle.
Well, think of it as a circle, yeah, I mean, I want them to be like arranged in a circle, there's only 3 of them, so it looks like a triangle, but they're on a circular plate. They're rotating. So in other words, if you look at this plate, and this plate, and this plate, they look different, but they are all
They rotate
exactly the
clockwise.
same thing. I didn't, like here, if I want to rearrange these guys, I gotta physically pick them up and rearrange them. But in a circle, you don't pick them up, you just rotate. So those 3 are the same, and so are these 3. These are all the same. So how many arrangements are there? Only 2. There aren't 6, there's only 2. Because all of the other ones are just rotations of the original. 8 people in a line, 8 factorial. 8 people in a circle, 7 factorial. It's 1 less factorial. So instead of having 3 factorial, I have 2 factorial. 1 less factorial. Because you have to take out all of the rotations. With 8 things, there would be 8 rotations, so 7 factorial.
That sandwich good.
All right? So, how about question? Look, you quit doing them. What's wrong with you?
I've been following.
How about question 29? 9 factorial. You've got to read carefully if you're arranging them in a row. It's n factorial. If you're arranging them in a circle, it's n minus 1.
5 factorial for the.
Number 30.
5 factorial.
How many ways can 6 keys be arranged on a key ring? 5 factorial, 120. Oh no, there's another issue.
Oh, God. Not another one.
Alright, so let me get my 5 keys. And they're in a circle, so I'll just call them A, B, C, D, and E. So there are my 5 keys arranged in a circle, right? And of course, there's lots of other arrangements. I'm not gonna write them all out, because you already told me there'd be 24 of them, so I'm not gonna write them all out. But if I did write them all out, listen, this is another idea, it's gonna complicate things. If I did write them out, another one of the, there'd be 24 of these, 4 factorial, another one of them that I would have would be this one.
Phone check?
That's your phone check?
Okay, so here I am, I have my keychain in my hand, and I am looking at it, and it looks just like this. This is what I see on my hand, okay? Then I pick it up and hold it up like this, keychain. I'm looking at this. What are you looking at? That. Are those 2 physical rearrangements?
No.
No, I didn't rearrange anything. I just looked at it from the other side. That is called a reflection. Boys and girls, we reflect very few things. So this is not going to be a common part of your problem. You reflect anything that is circular and can be held in your hand. So basically, a key ring, a bracelet, a necklace, that's about it. Well, you're arranging things, usually arranging mirrors. Yeah, it's items you're making into an arrangement.
So not the campfire.
Not the campfire, because you can't look at the campfire from the other side. You can't look at it from underneath.
Yeah.
So it's only things you can hold up and view on both sides.
Wait, so the
So the answer to problem 30
no, phone check.
is 5 oh, I was supposed to have 6 keys, sorry. The answer is 5 factorial over 2. 5 factorial over 2. Why is it 5 factorial? Because there's 6 keys in a circle. That drops down to 5. And why is it divided by 2? Because I can view it from
Wait, is it
both
30 or
sides.
31?
If it's something circular that Jack can look at and I can look at from each side, then you divide by 2.
Is there ever gonna be a problem where you can do from like 3 sides like a pyramid? No?
We're not doing it if there
It's
is.
not even in their ballpark.
Okay.
It's in general.
31. Another new idea. How many necklaces can be made from 1 blue, 1 yellow, 1 green, 1 orange, 1 pink, and 1 purple bead? Okay, now wait a second. 1, 2, 3, 4, 5, 6 beads. They're all different. But I'm making a necklace out of them, which means they're going into a circle. Okay, the answer to question B would be 5 factorial over 2. Because there are 6 beads, and you are putting them in a circle, so that makes 5. And divided by 2, because I can hold that necklace up and we can look at it from both sides. Now, what is the answer to A?
This is 6 factorial.
It's just 6 factorial.
6 factorial.
6 factorial over 2.
Oh,
6 factorial over 2. Now, why is question A back to 6 factorial? Because it has a clasp, and I heard somebody say it over here, as soon as you put a clasp on it, then it becomes a line.
Yeah.
Right? So you can either count the clasp as another bead, and say, okay, now I got 7 beads, so that brings me down to 6 factorial, or you can just think of it as a line. Either way, it's going to be 6 factorial.
Yeah.
So, A is 6 factorial over 2, B is 5 factorial over 2.
Yes.
All right, now we're gonna put it all together. Lord help us, number 32. Now we have 2 blue, 3 yellow, 1 green, 4 orange, 1 pink, 1 purple, and the beads of each color are alike. So now we have, like, remember our word where we had 4 S's? Now we have 4 orange beads. So, let's start at the beginning. How many beads are there? Count them up. 12? 12 beads?
You're St. Louis.
Did I count right?
Yeah.
5, 6, 10, 12 beads.
Or
Alright.
you can count one for the class.
A has no class. So 12 beads, necklace, no class, will be 11 factorial. Divided by 2 because of the reflections. And then divided by 2 factorial, 3 factorial, 4 factorial. Because having 2 blue beads is like having 2 L's in your word. And what do you do when you have repeated letters? You divide by that factorial. When you type this in, boys and girls, everything here is getting divided. I don't want to see any times. There is no times happening in this problem. It's 11 factorial divided by 2. Divided by 2 factorial, divided by 3 factorial, divided by 4 factorial.
This is a lot.
So here we go. It's a lot.
This is too much.
And is that with no?
Get over it.
Why are you doing this to us suckers?
Is that no class?
What brand is potential?
This is no class.
Under Armour.
So I got 69,300.
Yeah.
But I was being harassed by audience members, so I'm not sure if that's right or not. I think it's right. All right, now we're gonna do the last one. We're gonna do B. What? We got plenty of time. What happens, here's A, no class. What happens,
Same thing.
only thing that changes is, this becomes a 12.
Because it's like a line.
That's the only thing that happens.
So it's 690,300.
So the answer, okay, this was A. The answer to B should be 83,160.
Oh, yeah, I got it.
Now, we will finish this up next time, but we have hit on a bunch of pretty important ideas. So I need everybody to kind of review that for tomorrow. All right. So, you're working on your homework already?